All right, so last time we left off, our decompression UI was looking like this. Now I'm loading a file. We can load files and so on. We have this file picker. Now this frame here, this child frame, takes up too much space, right? We can see here it kind of extends too far and so on. So what we're going to try to do is fix that so that sort of other stuff can use this space. And if I click load more here, we can see we have fixed basically the spacing here. So we can see that the output kind of looks reasonable. Red here represents copying from previous places in the content and so on. And white is just literals. So let's take a look at how we will fix this here. I had some ideas. Here we were using begin child with a border and so on. The reason for it growing so much is because we're using 0, 0 here. The problem is we can't just set some kind of static height here, because if we were to do that, let's say, you know, I don't know, 50, doesn't matter so much, to be honest. We will simply be not giving enough space probably, or just too much space anyway, because it's static, right? So here we can see this. Now we have a scroll here, and this is awkward, right? So we kind of want it to be adaptive instead. And yeah, let's try instead to say, we're not going to have this be a child at all now. And we are going to say, I'm GUI begin group, and this will be end group. And this is no longer an if, so we can just sort of pull that there. Here I could defer this like this, and we can do this. So no, actually I can't do the defer probably. I don't know, we can try without the defer, or yeah, we can try without and then we'll try with and see what happens. So I have done a little bit of just sort of checking stuff, and what we're gonna do is we're gonna add, because we want the border, first let's try to sort of see what happens if I do this now. Now we can see here, we're basically fine, right? We have, effectively we have, we've drawn the stuff, and now we're gonna continue drawing, you know, below, right? So what we want to do is we want to draw a border around this area, right? So we have this begin group, we have end group. This now effectively, as far as I know, as far as I can tell, is now an item, right? This means we can effectively, we can add a rectangle around that item by using a few functions, right? So first of all, there is a thing called a draw list. So I am GUI get window draw list, like this. This gives us a draw list. We can view this, I guess, effectively probably as just, it's an opaque thing, it doesn't matter. It does have content, so if we say draw list dot something, we can see that there's stuff here, right? So the idea here is that we can actually use a function, a procedure on this called addRect, right? So I am GUI addRect draw list addRect, right? Because this is actually a method in C++ on this object, right? So actually we can use addRect EX. First we're going to use addRect, and then we're going to move to addRect EX, right? So this now will allow us to use this draw list right here, and then just say what are the bounds of this rectangle, right? And that's where a few interesting calls come in. Min item rect min and item rect max, and here we have this last argument call. We're gonna have to play around with a little bit because I'm not entirely sure what that actually kind of does. Oh, hang on, that's a color. It's most definitely a color, right? Let's see if that hypothesis holds true. In that case, let's do this because I kind of like that format more. Presumably this is actually a color. We're gonna try a little bit of stuff with that at some point. I think that should be it. If you're hearing, by the way, a drill in the background or something like this, it is demolition going on in our other apartment. So now we have a border around this stuff, right? Now we can play around with a few different versions of this, maybe. We could say, yeah, there's one thing that's going to be tricky. We want actually some padding in reality, right? We want padding around the content, but we want this on the left side as well, right? But naturally, stuff is not drawn necessarily. Yeah, we may have to kind of add padding here. So let's try to, okay, let's solve some very much more easy things first. So we have EX here. You can see that this also takes rounding and flags and thickness. So rounding, presumably, we would set some number, you know, I don't know what that might be, right? 0.5. I don't know what the number is going to be. We're going to have to play around with this, right? And then we had flags, which is probably this for now, and thickness. 0.5 is going to be our go-to here, right? Let's see what this gives us. Of course, loading the test file. The rounding does not seem to to be particularly big. So 0.5 probably is not going to do it. Let's say 50. If this is a scale from 0 to 255 or something, we're gonna see something interesting happening here. Probably. Oh yeah, now we're definitely seeing some rounding. We're definitely seeing some thickness going on. So we can probably lower the thickness a little bit and then keep the rounding probably. Right, and here we kind of see the problem in some ways. When we do, this is quite severe rounding to be clear, right? But we do see here that we need space to the left and to the right and so on, right? So we kind of want here to force space on the left and so on. And it's not clear to me how to do this actually. I do think that there is, I'm gonna see what this, okay, this doesn't have any documentation. But I wonder if we can actually kind of use this, right? Dummy would be something that takes up space, I suppose. I'm not sure, to be honest. I mean, even if it does, it's not gonna force stuff to the right. Right, so I'm not sure how we can force this to have more space, to be honest. I wonder a little bit how we'll do this. I mean, dummy is probably the best bet we have so far to do something, right? I'm gonna try adding dummies on the top and the bottom just to see if, like, does that extend the space on the top and the bottom, because that way we know it kind of works to some degree to do this, right? And it does, right? We can see here we have more space now on the top and the bottom, right? Because we were using these dummies, right? So the question now is, how do we solve this on the left side and the right side, right? Can you have a group inside of a group? Because if you have a group here, I'm gonna just try a little bit here. Begin group. We're gonna put this in a function at some point, by the way. This is now gonna be end group down there. And here I'm thinking, that we have this inner group, right? We want to get the width of that. Actually, we might not need this, right? The min. The min here and the max. Opa. Like this. Now we have these out here. We can definitely extend these. So that should not be an issue. These are just vec2s. We can add to them. It's not really an issue, right? The max here, we could even say plus. We could have a scalar value here, presumably, that we could use. So we could say plus 10 probably. Yeah. And then we don't actually need the dummies anymore because 10 is going to be added. Let's see. So the reason, by the way, we can use a scalar. Yeah, now we can see we have space on the bottom. So in the bottom and on the right, we have space now, right? We can remove this begin group and end group here. And now let's try adding 10 to min. No, minus 10. Minus 10, Rickard, you can't just add to that. So I want to kind of explain also how we can do. Okay, we have space now here. We have, this obviously goes outside now, and that's an issue. And we might want to actually make it larger. And the rounding probably should be a little bit less. Rounding was this. Here we can actually name these arguments like this. Let's see, flags. I'm gonna put that last. And thickness like this. Rounding, we can definitely go down a fair amount. And so here p min let's see exactly what this gives us now. Okay, it's obviously it's less rounded, a little bit more sensible maybe. Now we're drawing over this load more, however, right? And that's, you know, that's going to be an issue, right? Because we want to instead move this item, obviously. Like we've drawn the text where it should go here. We want to instead adjust for the padding that we've added, right? So that we kind of move this into the correct space. And that is potentially an issue, right? Let's put this in a procedure, right? Well, if we're putting this in a procedure, if it's general, right, in terms of drawing a bordered section, that would now, then we need this begin and we need an end regardless, right? Presumably. Yeah, so, okay, let's go first and just say, why can I add here? Because this is these two are, you can see these are arrays, or by slices rather, right? Why can I just sort of add to them, right? These are vec2s. We can see that a vec2 is really this here, right? Why can I add to them? Well, the reason is because Odin has array programming built in, right? So what's going to happen when we have these values here is that for each item we're going to do this operation, right? We could also use multiplication here and so on. We could add two vec2s together as well. So basically the thing that people usually use operator overloading for when it comes to vectors and so on, vectors and matrices, Odin has just out of the box, right? So this is kind of why it can get away with not having operator overloading, right? Obviously some people prefer to not have it, period, like at all, which I personally don't view as much of an issue. But then, you know, tastes may vary, right? So Odin has these for these very kind of these specific use cases because it is so common to use this, like in C++ and so on, right? So Odin kind of fills that use case and then says, you know, you can't just have it for other stuff though. Okay, so we have to push this somehow to the right. We have to push this somehow to the right. We want something. I'm trying now to come up with some kind of abstraction we can have here. Not an abstraction in terms of hiding something, but solving the common case for doing this. Because all of this content needs to be pushed, right? And I'm not entirely sure how we would do this necessarily, right? I'm wondering a little bit. Let me just sort of I'm going to try to just briefly check a few places here. Okay. What happens when we have two groups and we use same line between them? Now we do have the second group again. So now no, nothing is gonna happen when, no, we are actually doing something. Right, this is interesting. We could also actually say adjust this now. So now we're adjusting y as well. Oh, that did nothing. Why? Why did it do nothing? Well, it did nothing because right, the height doesn't matter there at all. We have to push it downwards some other way. Right, we're drawing this rect. So this group here, actually I don't need the group, do I? If I have a dummy and same line, it's gonna have the same effect. Let's see. Yeah, so y here doesn't matter for pushing this. Y doesn't matter for pushing this because same line is really kind of what's doing the pushing. By the way, we have probably some extra pushing here, so we should probably do 0, 0 here. Yeah, now we can see this is a little bit more precisely. Right, we have a 20 gap here. So we want to add that also, by the way, to the bottom. Actually, I am GUI same line, I am GUI dummy 2020 presumably. Oh, no, that just added stuff here. What am I even thinking? We don't need same line actually here. We do want this dummy here. And again, in that particular case, y is the only thing that matters actually, because we're extending something. Right, so we're extending it 20 here, right? So because what you have to realize, this rect is just drawn on top of stuff. It doesn't take up space. So when we use dummy, we are saying take up this space, right? And now that kind of gives me an idea actually. kind of. No. Actually, okay, this is not going to do what I think it does. Now we're just we're taking up more space here right now, right? And then we're adding the spacing on top of that as well. We are not moving this, which is what I want to accomplish, right? So let's think about this. We have successfully moved this 20. This doesn't matter here at all. And in this particular case, this shouldn't matter at all. So let's think about that, right? And verify that, right? Why is that the case? Right, we're getting the same actual result here now in terms of spacing, right? The reason is X matters here because we're using the same line. I'm saying on the same line that we have already moved 20 spaces on, right? Draw this group effectively, right? And here, down here, we're basically saying move 20 spaces, whatever it might be, in the Y axis after you've drawn these things. And it happens to be 20 because that's what add rect EX is doing here, right? We're adding 20 to each, right? So that all seems fine, right? The problem now is, again, we have not pushed the rect downwards. We've not been able to do that. And yeah, I'm wondering now, how do we do that? 0, 20. I'm just trying to figure out kind of the ways we can get this to move downwards and so on. Opa, those are the logs. That's not what I wanted. So now we've actually moved it. Now it seems actually fine in every dimension, I guess. Because we moved it here 20. We then said, hey, move 20 to the right, and then same line EX. Right, and it's the separate one up here that actually moves in the Y axis. This moves in the X axis, and then same lines, which means we're going to still be on the same height, and so on. Because again, let's just double check this now. This should not do it, right? Because we're using same line. And yeah, it doesn't, right? So we want this separate one, like this. Now, you might wonder, how do we put this in a neat procedure, right? The things we actually kind of want to put in a procedure mainly is this, the stuff around what we're doing, right? So we might have a begin and end for this. So let's try that first. Let's try that first. The actual syntax we might want to use here would be begin panel. Now the question is, should we make it like IM GUI? I think we can just say begin panel like this, right? Let me just double check. This IM GUI already do this, by the way. No, not really. It might have something like this, but I'm not super concerned that we're kind of remaking things, because it's interesting to do stuff, right? So here, I want to kind of do this effectively, begin panel, end panel. Now the question is, what parameters do we need, right? I don't think that 20 should be the thing necessarily. I think the rounding and the thickness might actually be something you want to just have, you know. So we probably want, at the very minimum, we want padding, right? Is going to be 20 here. Border should be, we're just going to say that that's always true or whatever, right? Color is going to be, yeah, I'm going to say that this is actually this. And yeah, actually, let's say begin panel is a procedure that takes padding, which is an F32, color for F32, and then we want rounding F32, thickness F32, and that should be basically it though, right? And you might wonder, okay, hang on, what are you doing here? We're just gonna, oh no, we can't do F32s there. No, we have to use bytes. Let's do bytes there. Because notice here, this is like this, right? And here we might actually, yeah, we're gonna see what this boils down to. It's fine. We'll sort this out. So that should be it though, right? Because the 20 shows up and so on and so forth, and that's fine. Here I actually want to say 1111 for now. No, hang on. We actually want to say 255. That will do the same thing that we did now. Rounding is going to be 10 and thickness is going to be 1. These are the same parameters we were using before. End panel doesn't take any arguments. And here I want to just sort of stick that code in there. I want to stick that code in there. Nope. And group. Ah, here we actually need some of these, obviously. Right. That's interesting. Actually, we don't need the rounding and the thickness for these initial ones. We don't need the color actually either. We need the padding. Let's do this. This is going to be a funky interface maybe, but it's all driven by basically what do we need. This is the padding like this. And this also takes padding actually. And of course here you can be wrong. And I think that is maybe not what we want to do necessarily actually. We might have to use a little bit of stateful stuff here. Because I don't think we can just take this. We could actually. We could take this as a procedure. The problem is you don't have closures in Odin, right? So making a procedure that actually uses some kind of data is not something you can do. You would have to pass a pointer and then cast that pointer and so on and so forth, right? So you can't just sort of say, oh, frame descriptor is closed over in this procedure. So that's not something you can do. But we could, okay, let's try an alternative thing here, right? Let's call this panel, draw panel, like this, right? Now we're gonna put all of our code inside of this one. And we're going to say basically, hang on, let's take all of these arguments now, again. Right, so now we're taking all of them. And of course, in between here, draw stuff, right? This is this stuff here, right? But if this is a general thing, well, obviously we want to take some kind of procedure, right? And here we want to say draw proc is a proc of something, right? It takes data, which is a raw pointer, and it returns void. I think this should be fine. This should probably be fine. And here now we can say draw proc like this with whatever data we have. And of course, data will be raw pointer here, like this. And panel is not a thing. Now, draw, let's see here. We have a proc, which is we want to draw our frame descriptor. Is a proc that takes data as a raw pointer and it casts it indeed to a frame descriptor. This is the thing we're reading here, right? Transmute, sure. Like this. Now note, I haven't done this at all. I don't know that this is the best solution, but we're gonna try it. There's no shame in trying this stuff and seeing what we end up with. Let's just do some basic verification that stuff makes some kind of sense here. We obviously have not been using any of our parameters here. This is the padding. This here is going to be transmute, right, of basically we're going to transmute this into an I32. Yeah, an I32 color like this. For one in every piece, it's not going to matter. So we're going to have to figure out how to do this. I'm going to show what I mean by this. So now we have this procedure here, draw frame descriptor, right? Here we're going to say draw panel with draw proc equals draw frame descriptor, and with data being a pointer to frame descriptor. Ah, it's a U32. Never mind. I mean, not that it matters actually. This is just it is just bytes, right? We saw this before when we were passing 0x, FFFF, and so on, right? It's just some bytes in a certain order. We might be crashing and stuff here. We'll see. Not a big deal. Okay, it just works. Fair enough. Right, so okay, let's go over what we've done, right? So first of all, I don't know, I haven't shown this. I've mentioned it very, very briefly before. You can define procs wherever you want in Odin. That doesn't mean that it closes over anything. You'll note here, if I were to say, oh, we can just use frame descriptor, let's say this, right? Odin doesn't understand what that means, right? In other languages here, you would basically have access to frame descriptor, right? If they are higher level languages, right? Because they have something called closures. So when you create an anonymous function, you can close over variables. These variables are now part of the anonymous function, right? They're part of the function in its memory. In C++, you can be very specific about, should I copy a reference to this thing? Should I copy the thing itself, and so on? In C++, you actually have closures. Like, you can actually guide basically the language towards using this pattern. In Odin, we have nothing, right? Nothing in terms of closures. There are no closures. What we do take is instead data pointers, right? So here I'm saying, this draw function, right, that we have up here, has to take a data pointer, right? And when you use draw panel, you say, hey, here's the draw proc I want you to use, right? That's, in our case, draw frame descriptor, right? And here's the data pointer that I want you to pass to that draw proc. So draw proc here takes this data pointer, that is the contract that is established, right? And in this particular case here, our draw frame descriptor function is a draw proc, right? And then that says, oh, I'm going to regard this data as a frame descriptor, right? And then it's going to do what it needs to do, and so on. And that allows us to basically say, you can pass any draw proc and data pointer here as long as they make sense together, right? And we will be able to draw that with padding, with a certain color, and so on. And the end result is effectively abstracting kind of the same pattern we saw before, right? And now we can have these begin group, end group, and so on together, right? We don't need now to have a begin and end call, right? And so we can use this pattern instead. Draw panel is basically this. And now we can freely say now, okay, hang on, I don't need to have these in line, you know? They're not material necessarily to the code down there, right? So I can actually kind of just move these out maybe to here. I'm gonna move this to here. And now this is the exact same code, because no matter where you define these, it's not like you're gonna have closures, right? And they just need to be basically accessible in terms of the actual source hierarchy, right? I can't define a function lower in the hierarchy than where I'm using it, but I can define it wherever I want, right? So you can have functions that are defined inside of other functions and so on. That does not mean that they're going to be able to use the state inside of those functions, right? It all works exactly as if you had it at the top level, right? Because Odin doesn't do any fancy stuff with closures and so on, which you could view as, by the way, a deficiency. I don't want to make, you know, personally, I don't think it matters that much. You saw that we could solve this problem, right? And it does actually simplify some stuff. Closures are not necessarily trivial always to reason about. Just to kind of go into this a little bit more, right? In C++, I actually kind of think it's a mix. C++ gives you extreme control over what should happen. Hang on, one of my screens went out. So C++ gives you a lot of control over what's going to happen when you have one of these lambdas, right? And so on. So if we are using lambdas, we can basically control, you know, no, this needs to be copied this way, and so on. The problem there is you still have failure modes like, oh, I have a reference to this thing, and so on. And depending on entirely which types we have, and so on, that reference may or may not be valid at the call time, right? And so on. So it can get a little bit, you know, difficult. This is the same failure mode we have here, by the way, right? If I have a pointer to something and that pointer is no longer valid, guess what? We're not going to get stuff that works, right? I guess the failure mode you can't actually have in Odin is this kind of copying, where you end up copying something without it being clear and so on. And of course in C++ you can also end up with a lot of strange things happening because you're using types like, this is a unique pointer, this is a shared pointer, this is a something pointer, and so on and so on. You kind of, when you stack these things on top of each other, you get behavior that is not necessarily very easy to reason about, right? Whereas the model in Odin is really, you can't really stack anything on top of anything else here. It's just a pointer to something. It's going to work exactly as a pointer to something would, and so on. So it's kind of, you can't actually get something that is particularly complex necessarily. You'll just end up crashing whenever you try to use this, probably with a seg fault or something. And that's it. So let's kind of look at our current situation and see where we're at. And we're gonna take stock here and say, now we have this. And I think that's fine. Okay, we're gonna leave that like this for now. Now we actually have this output pretty neatly, to be honest. I think we might have a stopping point here. So one thing I want to kind of, first let's get something basic out of the way, because it's annoying me a little bit that I want to selectable, when we load a file, I want to actually clear the things we already have in our rights. Clear rights. Clear does that not work for dynamic arrays? That would be surprising, would it not? How would I deal with this now in that case? Hang on. Hang on. Okay, so is this just not in scope? It could be, right? So let's go back down there and see. Let's add the call that is evidently failing. Clear rights. I think this is the call we want. So I'm going to say that is now failing, right? And then we're going to say like this. And now we don't have it, yeah. So that's all fine. Now let's see if it works, because we don't know that. Now I'm loading. Now I'm saying, hey, I want to load a new thing. It's actually the same thing, but that's fine. But there's something, we're still continuing from the place we were. And that's probably not what we want to do. Presumably that's because our copy index remains the same. And so we want to fix that as well. There's also probably a bunch of other stuff we want to. Here I'm actually going to say static like this. Copy index is 0 there. What else do we need to adjust, right? The file data. Now the file data is, yeah, the frame descriptor we are loading here is going to be the new stuff. We have the frame block. Current frame block needs to be reset as well. Actually, let's take all of these and move them up to and here we want to kind of reset all of these. We could make actually a structure for this. Keyword being could. Remaining block data block, current frame block. Current frame block we do want to reset here. Let's try this. Remaining block data. I'm not sure if nil is should be the thing here, but we will try this and we will see. Load more, load more. So the first one works, that's all fine. And now we're saying, hey, I want to do this again. And it works. Now if I do this again, it works just fine. Let's load some other data just to see that that works. All right. This is certainly looking nice. I have one idea. I think we can kind of stop here now with the things we're doing. I do want to show something that I want to do. So here, I was thinking, when you mouse over these sections here, I want to kind of show the data that these things entail, right? In a tooltip. So when you mouse over these, I want to show what data was that part of, and sort of what is the actual data that represents that section, for example, right? Probably in hex or something like this, so that you can kind of go through and see, because one, this is very easy now to, when you do this, right, you can see, oh, what bytes were those in my file, right? Because then you can use dhex, for example, to see the hex of your file, and you can see, oh, that's that part, right? That's where we are in the file. That makes it incredibly easy to see, to diagnose potential issues, for example, right? So I want to do that, right? So when you mouse over it, that's going to be the next video, very likely. We might also think about sort of if we want to do something interesting in terms of showing other information about our file. I'm not sure. We will come up with something. But yeah, so here's where we are right now. The thing we did here was we created this kind of panel-like structure. We abstracted this, and we used actually these procedures, and we used data pointers. So we have this, let's just do draw panel. Opa. Actually, let's try a feature that see here. I don't remember which key this is. Ah, there you go. Draw panel. So what I'm using here, by the way, is fairly recently the creator of OLS added support for workspace symbol search. So for example, if I were to here, let's just try this for the time being. Yeah, that's not the one we want. So if I were to, for example, say, I want to go to data. No, hang on, that's not the one. No, I'm unsure. So this is inside of a file. Yeah, document symbols. Let me just double check this. Which workspace symbol is local leader S. But that's the, hang on, what? That's what I executed though. Local leader S, lowercase s. Now I'm just confused. Let me, no, okay, that is the one that's currently not working. I don't know why that would be. Anyway, okay, let's leave that for now. I'm gonna take a look at that later. We created basically an abstraction for drawing this panel because if we want to use this with anything else, we would want to kind of reuse this kind of thing, right? So we have this draw panel procedure, right? It takes a draw proc, right? Which takes itself a data pointer, right? And this conventionally also is called user data, like this. I think we can just say data like this. Actually, let's say user data, it doesn't matter. And here, we pass also what data to actually draw this with, right? This is going to be passed to draw proc, right? And then we have our padding, color, rounding, thickness. This is just specific to our particular use case. We pad by pushing content downwards first, and then to the side. And then we use same line EX here to say on the same row, effectively, right, as this content that we've pushed to the side, right? Begin a group, draw the thing we wanted to actually draw with the draw proc, passing data to it, right? Let's just say user data here. No, actually, never mind. Actually, I think we can, I prefer if it just says data. Then we end this group, we get the size of that group, and we draw a rectangle around it, right? So this is where some of our padding and so on comes in, right? We're basically saying the minimum place, right? The lowest in terms of X and Y, right? Minus the padding, right? And then the maximum plus the padding we have, right? And here, what we're using here, because these are actually, these are arrays of floats. Here we're using array programming and adding the scalar value to each value, right? So we can say plus, and it will apply to all of those, right? In the array. Then we have this transmute U32 here, color, right? And we can experiment a little bit with that one because I did say we would. We have our rounding, thickness, and flags, blah blah blah, and then we actually push the content. We add content below the thing that we're doing, right? And the effect of all of this, right, is we get this thing that draws around our stuff, right? When we actually use this, right, it looks like this. Draw panel with a draw proc being draw frame descriptor, right? The data being the frame descriptor, and padding and so on and so forth, right? And here I did promise we would take a look at this here. What I want to do now is I want to set one of these to 0, right? and I'm going to set this one to 0. And now we will kind of see what order this is actually in. Yeah, that should be fine. Yeah, let's do this actually. My hypothesis is that this is going to end up being the alpha. This is blue, green, and red. And so what we're going to see is blue for the border when we run this now. I just want to show also how you actually, this is our draw proc, right? Here we just take the data that we're given, right? We say frame descriptor is that data, but regarded as a pointer to a frame descriptor. And then we do our stuff. And that's really it, right? We don't need to do more. Let's move this to be next to our draw panel. Like this. We could move this to a separate file if we wanted to. It would be a reasonable decision, I think. But let's look at our colors and stuff here, right? Because we did say that we would look at that, and I think it will be reasonable to fix that so that I don't forget until next time. Now we can see, okay, my hypothesis was wrong. One of these zeros was the alpha channel, right? Let's test that hypothesis and switch this around, 0, 0, right? 255, 255. Now we should still probably see blue. Yeah, this will give us a blue border, right? And this is actually neat because now if I wanted the red one, I could just add it here. Let's test that hypothesis just real quick. So now it's actually in the quote-unquote correct order, which is fine. That actually gives us less to bother about, right? We're not at all concerned. So what we can do here could be, you know, let's say 128, 128, 128 maybe, and full alpha. Opa, ping stack overflow, not what we want to do. There you go. Now we have this kind of grayish border and so on here, right? Very easy to work with. This is fine. And so this is now quote unquote the correct order, right? Red, green, and blue, right? You get this kind of control over it, right? And all we're doing, just to be clear here, right? We're taking this array of 4 bytes, right? Because draw panel, you can say it takes array of byte, right? We're taking that and then we're transmuting it to a U32, right? So this is all completely fine, right? We're just saying regard these 4 bytes as a U32, right? And internally, this is probably what IMGUI does anyway, right? This argument here is obviously a U32, right? But you set this value basically with just 4 different values, right? RGBA, right? So we have just sort of made that more obvious anyway, right, in our interface. So with that, I think we are kind of, we're done for this video. Just to kind of reiterate what we're going to try to do in the next video is we're going to try to add tooltips to the output sections that we have. So here we have this text here, and I want to say, for example, if I mouse over package, I should be able to see the data that was used to build up that section, right? Likewise, for frame, I want to see what data was it that said that this was underscore frame, right? That was being copied and so on. And probably some kind of block index, sequence index maybe here. Maybe, we'll see. In any case, we want tooltips. When we mouse over these things, we want to see where did that data come from? What is it that says that should be the data, right? In the file, basically. So you can diagnose a file very easily that way. So that's the plan for next video. I guess that's it. Have a nice day and ciao.